Alrighty, as a few more people filter in, we will get started today. So first and foremost, hello and welcome to our Drinking Water Wise webinar series. Today's topic is Groundwater 101. So I'm your host, Kelsey LeBlanc from Cataraqui Conservation. I also have Natasha, Haven, and Marika on the call with me today. They're from Quinte, Cataraqui, and Rideau Valley, respectively. They'll be helping to moderate the chat and providing some technical support where needed. Excuse me. So before we jump in to the meat of the presentation, I'll just mention a few housekeeping items. So the first being, as you may have seen pop up on your screen, the webinar is being recorded and will be available for viewing on YouTube in the next couple of days. All participants are also asked to keep muted and their cameras off for the duration of the webinar. We do ask that if you have any questions throughout the presentations, you populate them within the chat function, and our panelists will be able to address those questions at the end of the presentation. Other than that, if you're experiencing any technical difficulties, you can contact Natasha Matthew at the email right there on the slide. Alrighty. So with that being said, I've populated our agenda here on the slide for us all today. So I'm going to start by going through a brief introduction of the best practices for source water protection. And then I'm going to hand it over to our guest speakers today, Trish and Kyle from the Ontario Groundwater Association, to discuss groundwater and all the lovely things that come with it. And then we'll finish up today with some of the question and answer period. We'll start with the questions that were submitted during registration and follow up with any questions populated within the chat function. So to begin today, first and foremost, what are the best practices for source water protection? So the best practices are a voluntary guidance document developed by the Ministry of the Environment, Conservation and Parks with a goal to aid in protecting drinking water sources that are not protected by 1, the Clean Water Act, or 2, a source protection plan. So all in all, this document is particularly applicable to private drinking water systems such as rural residents. This document, the best practices, walks the reader through how to identify vulnerability in their drinking water system, how to assess the local setting, identify potential risks, and how to manage those risks to better protect their source. It includes useful information for private residents, municipalities, and other agencies and associations. Excuse me. At this time, I believe Marika just populated in the chat a link to the best practices document if you'd like to take a look and get some more information. So now that we know what the best practices are, why are they important? So as I alluded to a little bit on the previous slide, the best practices were created because there's a clear gap in drinking water protection between those who receive their water from municipal sources and those who rely on private drinking water systems. As you can see in this diagram, private system owners have the responsibility of ensuring that their drinking water is safe by doing their own treatment, their own testing, their own maintenance. On the other hand, if you look at the municipal systems, there's that multi-barrier approach where trained professionals do the treatment, the testing, and things of that nature. So in addition to that gap, I've listed on the slide here a couple of other reasons that the best practices are important. The first being, it can aid in protecting human health and the environment. It can extend drinking water system life by using some of those tips and tricks within the guidance document to maintain your system and ensure that it's operating properly. It can also help by avoiding high cost of cleanup of contaminated sources, the requirement to seek a new source if your original source becomes contaminated, as well as reducing the high cost of potential required increased treatment needs. The best practices are also great to increase public awareness and accountability for drinking water stewardship. And lastly, they can aid in land use planning decisions.
I'll see what I can find there. Yeah.
So over the next 2 slides, we've highlighted a few measures that private system owners can undertake to better protect their drinking water system and supply. So the first here you've probably heard many times before, but testing your drinking water regularly is a great step to ensuring the quality of your drinking water. As many of you may know, the health unit has free sampling bottles that you can collect, test your water, and send back to test for microbiological parameters. If you are interested in testing other parameters, you can seek out an accredited lab to undertake that sampling. The next one here is creating an inventory of potential contamination activities. So this could be going around your property and seeing if there's anything such as fuel or pesticides or other potential threats to drinking water that could be located near your well. Going hand in hand with that, the next tip is to implement a protection zone around your source. This is ensuring that any potential contamination activities are either managed properly or are not existing within your protection zone. The next is to visually inspect your well and septic system annually or on a regular basis. This ensures that potential contamination of your well and septic is not occurring and it's being properly maintained and there's no existing damage. With that, we also recommend pumping out your septic system every 3 to 5 years. If you have any questions about the efficacy of your current system or if it requires pump out, we recommend that you reach out to a licensed septic contractor to take a look. Sorry, I think I have a little bit of feedback. If you're unmuted, please just make sure that you're muted. Thank you. And then the next tip here on the slide is to use eco-friendly alternatives for commercial products. So an example of this could be reducing or eliminating the use of pesticides on your property or using alternatives that would have less of an environmental impact and the potential to impact your drinking water. So the last 4 recommendations here, the first being conserve water when possible. So when we talk about the best practices, we're not only talking about the quality of our water, but also the quantity. So water conservation can help make sure that your drinking water source is plentiful and is not drying up due to excessive use. The next is disposing of hazardous waste at the appropriate locations. So it's important to go check your municipal website and identify whether they have any municipal hazardous waste drop-off days or any depots. Some of these examples of hazardous waste or household hazardous waste could include light bulbs, household pesticides, paints, cleaning products, things of that nature. It's important that these are disposed of properly and not through the mainstream garbage and recycling. The next here is to inspect and install double-walled tanks for fuel storage. Fuel can be a potential threat to drinking water, so ensuring it's properly contained and the tanks that it's stored in are not damaged or rusting is a great way to protect your drinking water. And lastly, if you're on a waterfront property, it's important to keep a shoreline buffer to reduce surface water runoff. This can aid in protecting the surface water of your nearby drinking water source. So with that, this concludes our short discussion about the best practices. And I'm actually going to turn it over to our guest speakers. So as you can see on the slide here, we have Trish and Kyle here today from the Ontario Groundwater Association to speak to us today about groundwater. So thank you both so much for coming. Trish is the office manager with the Ontario Groundwater Association. She's passionate about education and advocacy, focusing on raising awareness about groundwater conservation and sustainable practices. Trish is dedicated to driving the Ontario Groundwater Association's strategic initiatives, enhancing member services, and expanding educational programs. Her vision is to position the OGWA as a leading authority in groundwater management and support the industry's growth and sustainability. And Kyle is the Vice President of the Education Committee at OGWA and has volunteered with the association since 2016. He's a graduate of Fleming College's Natural Resources, Drilling, and Natural Blasting program and has been a licensed well technician in Ontario since 2009. He's contributed to groundwater investigations in Canada, the US, South America, and all the way down to Bermuda. So Kyle's also a project manager at Aardvark Drilling Inc., where he has managed a multitude of well construction, rehabilitation, and abandonment projects for over 15 years. So at this time, I'm going to pass it over to our guest speakers and ask that you share your screen. Stop sharing mine. Excuse me.
Hello, everyone. Thank you for joining us. I will just note I am kind of recovering from the flu. I apologize if I don't sound my best today. But welcome to our WellWise presentation. Again, my name is Trish. And I'm just going to dive right in here. So what is groundwater? Groundwater is the water that is found beneath the Earth's surface, stored in soil, sand, and rock formations called aquifers. In Ontario specifically, it plays a crucial role in supplying drinking water, supporting agriculture, industry, and natural ecosystems. It's recharged by precipitation and essential to maintaining the flow of rivers and lakes, especially during our dry periods. Protecting this vital resource is critical to ensuring clean, safe water for communities and preserving Ontario's environmental health. At this point, about 3 million Ontarians depend on more than 750 domestic and municipal wells for water. There are many old wells throughout Ontario that were installed prior to the introduction of minimum construction, maintenance, or abandonment standards. We'll talk a little bit more about that later. So the Ontario Groundwater Association is celebrating 72 years of protecting and promoting groundwater. In 1952, Ontario mandated water well record filings for all new wells. As a result, the water well drillers organized, and their first meeting was held in Tillsonburg, Ontario in 1952. As a result, the Water Well Association was created as a not-for-profit. It's now changed to the Ontario Groundwater Association to facilitate various sectors of the groundwater industry coming together for the delivery of safe and clean water supplies throughout the province. I'm going to talk a little bit about the hydrological cycle. Water on Earth moves in a continuous cycle of evaporation, condensation, and precipitation. It happens both below and on the Earth's surface. Groundwater is precipitation that has percolated through sand and rock layers into underground reservoirs called aquifers. And over the next few slides, we'll continue talking about the hydrological cycle and those aquifers. In this slide, you'll see a diagram of how precipitation infiltrates and percolates into our water table, then flowing as groundwater through our surface, and then recharging back through rivers, oceans, and lakes into evaporation. So precipitation infiltrates the ground and is stored as groundwater. This study of how it moves through the earth is called hydrogeology. And geology determines the location, pathways, and the speed at which the groundwater flows. An aquifer is a geological formation that stores and transmits the groundwater. Confined ones are trapped beneath layers of rock or clay that are usually very dense, and unconfined aquifers are covered by more permeable soil or sediment and sometimes exposed to open air. In this slide, you'll see a vulnerable open aquifer. They're typically of kind of a quarry-like nature. So this one is the Dolomieu Quarry in Guelph, and you can see how open and vulnerable that is. Open or unconfined aquifers are those where the groundwater is directly in contact with the surface. They are more vulnerable because there is less protection from surface pollutants and no natural filtration. Due to their direct connection with surface environments, open aquifers can be more susceptible to the contamination from agricultural runoff, industrial activities, and other surface pollutants, including swimming. In Ontario, open aquifers are often found in regions with significant glacial deposits or sedimentary rock formations, and I'm going to go through a few of those locations and aquifers in Ontario. So in Southern Ontario, particularly around the GTA, Hamilton, and Niagara, these aquifers are composed of sand and gravel deposits left by glacial activity, They're highly productive and often tapped for municipal and agricultural water supplies. The Great Lakes and southwestern Ontario, these are often very influenced by proximity to the Great Lakes, with groundwater flowing into and out of the lake system. They can become susceptible to contamination from surface activities. In Muskoka, Haliburton, this region contains a lot of shallow aquifers with significant glacial deposits. They provide important water sources for many local communities and are often characterized by their accessibility and vulnerability to surface contamination, meaning they're shallow. In Ottawa, the aquifer system is typically unconfined and composed of various sediment types, including sand and gravel. It serves as a very crucial water source for the communities in the valley. And here you can see one of those wonderful swimming quarries and how a vulnerable aquifer can very easily become contaminated from activities such as swimming. We're going to talk a little bit more about groundwater contaminants. They can enter groundwater through processes such as leaching, spills, and runoffs, and directly impact drinking water supplies, ecosystems, and agricultural uses. Effective management and monitoring are essential to prevent groundwater contamination. A contaminant is a substance that, when introduced to groundwater systems, adversely affects the quality and makes it unsafe or unsuitable to use. In this slide, we have a diagram just showing how the different contaminants can move through the different aquifers. Some of them are more free-flowing, some of them float, and some of them sink. But all three have very big impacts on our aquifers. So I'm going to go through a few of those, a few very common contaminants. So nitrates from agricultural runoff and fertilizers and septic systems. The impact of these can have very high levels of health issues, such as blue baby syndrome, and cause effects on aquatic systems. I'm sure we've all talked about pesticides and herbicides a lot, and the improper disposal of those chemicals can lead to health problems, including cancer, endocrine disruption, and affect aquatic life again. Heavy metals such as lead, arsenic, mercury come from sources such as industrial activities, mining operations, and contaminated landfills. Long-term exposure to these can have serious health impacts, such as neurological damage, cancer, and kidney disease. We have volatile organic compounds such as benzene, found in industrial solvents, fuel spills, and again, improper disposal of chemicals. They can cause a range of health problems, including cancer and liver damage. Pathogens such as bacteria, very easily flowing, come from sewage spills, agricultural runoff, failing septic systems, and even pet waste. They can cause severe gastrointestinal issues as well as other infections. Salts, sodium chloride, such as our road salts. These can have an effect on the taste of water, harm plant life, and lead to soil degradation. High sodium can also have severe impacts on your health. I've got another diagram here just showing how contaminants can move from even non-source points to direct source points into our groundwater. I'm going to continue on with some more contaminants here. So pharmaceuticals and personal care products, your prescription drugs, over-the-counter medications, cosmetics, improper disposal such as flushing and runoff into wastewater treatment plants can disrupt endocrine systems and impact our aquatic life. industrial chemicals, the chlorinated solvents, and even transformers exploding on your property with that leaching into the ground. These can have long-term health problems and environmental contaminations. Household detergents and cleaning agents, such as soap, bleach, and laundry detergents. When using these for washing, siding, outdoor cleaning, or any improper disposal, these introduce phosphates, surfactants, and other chemicals into our groundwater, potentially causing harmful contamination. Petroleum products from car washing. Motor oil and gasoline residues can come off when washing your car. And when washing on driveways or laneways, the runoff can flow into our storm drains. The impact can introduce hydrocarbons and heavy metals into the groundwater, which can harm aquatic life systems and pose health risks. To prevent environmental contamination here, avoid washing your car on driveways and other areas where runoff might enter storm drains. Instead, consider using commercial car wash systems that treat their wastewater. Swimming pool chemicals such as chlorine and bromine. The improper disposal of pool water or overflow from poorly maintained pools can lead to elevated levels of chlorine and other chemicals in our groundwater, potentially affecting water quality. A big one in the news these days, you'll probably have heard of a lot, is PFAS. PFAS are commonly found in firefighting foams, stain-resistant coatings for carpets and fabrics, non-stick cookware, and other industrial applications. These substances are used because of their water and grease-resistant properties. However, they are persistent in the environment and they do not break down easily. They can remain in the soil and water for extended periods of time. As these substances can accumulate in the human body over time, it leads to potential health risks. Exposure to PFAS has been linked to various health issues, including increased risk of cancer, liver damage, thyroid disease, and adverse effects on the immune system. Due to their ability to sink as they are heavy and accumulate in the environment, reservoirs, and biological systems, PFAS can lead to long-term contamination problems, making them very difficult for both the environment and public health. So what can we do to prevent our groundwater contamination? Dispose of household chemicals, automotive fluids, and pharmaceuticals properly. Wash your cars at commercial car washes that treat their wastewater. Regularly check and maintain swimming pools to avoid chemical overflow and proper disposal of pool water. Opt for biodegradable and less harmful cleaning products to reduce the impact on our groundwater. And limit the use of products containing PFAS, following local guidelines for disposal of such substances. So there are quite a few source water maps available through municipalities and conservation authorities that highlight where sources are for groundwater, their vulnerability, and the landscape. This one's one just showing the region of Waterloo. And on our next slide, you will see the Quinte area. This map shows almost every well in the Quinte area and its aquifer vulnerability. As you can see, it's very high on the vulnerability map. This area of Napanee is interesting. The concentrated area of blue to the right shows the water well records of several monitoring and test sites near a waste management site. These tests were conducted to monitor the contamination flow and potential risk to the neighboring vulnerable areas. So I'll go into a little bit about groundwater filtration and well protection. In Ontario, natural filtration processes play a crucial role in the quality of our groundwater. These processes involve natural ability for soil and geological formations to filter and purify water as it moves through the environment. Soil filtration. Surface soil. So this is when rainwater or surface water infiltrates the soil, and the particles in the soil act as a physical filter. Organic matter can also, soil can also contain organic matter that helps break down the contaminants and pollutants through the biological process. In many parts of Ontario, sand and gravel deposits act as natural filters. These materials have large pore spaces and allow water to flow through while trapping larger particles and impurities. As water moves through these sedimentary layers through the strata, it undergoes physical filtration with finer particles and some contaminants being removed. Through bedrock formations, such as karst aquifers, these are regions with limestone or other soluble bedrock, the natural filtration can occur as water flows through cracks and fissures. Fractured bedrock. In fractured bedrock or jointed bedrock formation, groundwater flows through the fractures and can naturally filter out the particles and some contaminants. Wetlands act as natural filters by trapping sediments and pollutants before they reach groundwater. They also facilitate chemical and biological processes that break down the contaminants. Highly vegetated areas along bodies of water help filter runoff. The roots and organic matter in these zones capture and degrade pollutants. Clay deposits, which can be very thick in some areas, clay acts as a natural barrier to groundwater. It's less permeable, so it can help filter out some contaminants by limiting the movement of pollutants through groundwater. There are a couple natural chemical processes, such as ion exchange. Certain geological formations can perform ion exchange, where contaminants in groundwater are exchanged with less harmful ions from minerals in the rock. We also have biodegradation. Microbial activities in soil and aquifer materials can break down organic contaminants, reducing their concentrations in the groundwater. And lastly, we have aquifer recharge zones. These are areas where surface water infiltrates and recharges aquifers and are important to maintaining groundwater quality. In the next slide, I'll just have a little image of the Quinte area and the number of recharge zones you have. They're all highlighted in yellow, and the purple line, of course, is the Quinte area. So we did talk a little bit about older wells in Ontario, and many shallow or bored wells are quite old. They don't meet the current regulations and are more susceptible to contamination and can be very expensive to maintain and repair. Accessing and maintaining old wells, especially those in basements of old homes, can be inconvenient and very challenging. Upgrading to more modern well systems offers significant advantages, and we'll go through a few of those advantages in later slides as well. So in this slide, you see a couple of images of poor wells. The one on the left is a dug bored well with the cap broken, leaving it open to contaminants into the groundwater. And on the right, you'll see an old well in the basement of a home. You can see how accessing this well for maintenance would be very difficult and challenging. So the benefits of upgrading your dug or bored well. Upgrading to a modern well system provides enhanced protection and reliability. These wells are designed to minimize the risk of contamination more effectively than the older wells. They have reduced contamination risks. Dug wells, like I said, are more susceptible to the contamination from surface runoff and other environmental factors. Newer well designs feature advanced filtration systems and much better construction standards. They have long-term safety. So investing in a newer well system ensures compliance with current regulations and standards, providing long-term safety. They have enhanced efficiencies. Newer systems often include improved pumps and filtration technology, resulting in more efficient water extraction. And as I said, serviceability of newer wells. Modern wells are designed for easier maintenance and repair. Their advanced construction and technology allow for quicker servicing and less frequent issues, ensuring your water supply remains reliable with minimal downtime. In this slide, you have an image of a dug or bored well. These are, again, the older wells. So a new drilled well with a pitless adapter. New wells are constructed with up-to-date materials and technology, ensuring longevity and reducing the need for frequent repairs. They are custom designed to suit specific groundwater conditions and your user needs. Modern drilling techniques and materials minimize maintenance requirements associated with costs over time, reducing your maintenance costs. Newly drilled wells are less likely to experience issues like contamination or malfunction. Professional installation. This is key. To be conducted by a licensed well technician who adhere to the best practices, ensuring the well is properly installed and meets all safety and regulatory standards. Advanced technology. Using the best technology and equipment, such as high-quality pumps and filtration systems to enhance our well's functionality and reliability. They're also equipped with pitless adapters for more convenient and durable connection between the well and plumbing systems. These adapters eliminate the need for a well pit, reducing the risk of contamination and making maintenance easier. Adaptable maintenance. They're easier to implement routine maintenance and upgrades due to the modern design features. In the next slide, you'll see the images of a new drilled well. New wells are built to meet current local and regulations, ensuring legal compliance and reducing the risk of future issues. So you'll see on the right, the image showing a proper well with well tag and vermin-proof well cap. In the next, you'll see a couple images of wells that are not properly maintained and are very open to contaminants reaching the groundwater. So let's talk a little bit about well owner's responsibility. A well owner is the owner of the land on which a well is situated. This also includes a tenant or leasee of the land and the well purchaser. The owner is responsible for your regular inspection to be done annually and after any significant events such as heavy rain or flooding. Your key checks. Ensure the wellhead is secure, clean, and free of debris. Check for any visible damage or deterioration to the casing and seals. Ensure your well lid is vermin-proof and undamaged. You need to test your water at least 3 times a year for common contaminants, such as bacteria, nitrates, and pH. You're responsible for your well maintenance and repairs. Hire a licensed well professional for any necessary repairs or maintenance. Ensure that your pump and other equipment are functioning properly. Always clean and disinfect your well and pump systems when any issues arise. Maintain records of all well maintenance activities water quality test results that you've had done, and any repairs made to your well. Keep a log of changes or issues so that you can track your well's performance over time. Avoid placing landscaping or lawn decorations near or on top of your well. Ensure it always remains visible and unobstructed. Avoid contamination by keeping septic systems and other sources of contamination away from the well. Avoid disposing of chemicals or waste near your well. And ensure the wellhead is properly capped and the area around the well is elevated to prevent contamination from surface water. Be emergency ready. Have a plan in place for potential well contamination or failure, including alternative water sources. Keep contact details for well repair professionals or visit ogw.ca for your professionals. Adhere to local regulations. So follow any local guidelines or regulations for well construction, maintenance, and the water quality. Ensure any modifications or upgrades are meeting those standards. Decommissioning of a well, very important. Any unused well or well not being retained for any future use must be properly decommissioned. The well owner is responsible for retaining a qualified person to retain and to complete this work. Why your well maintenance matters. Regular maintenance and usage. Very important to actually use your well to ensure that your well water remains safe to drink and use. Proper care can extend the lifespan of your well and reduce costly repairs. Properly maintained wells help protect groundwater and local systems. So in this next slide, you have a couple of the well records. On the left, you've got an older well record, and as you can see, it didn't have as much detail as the newer well records now require for licensed well technicians to fill out for every well. Have well in need? You can visit our website to find a licensed contractor or licensed well technician. We have an online membership directory as well as a map to help you find ones within your area. Why it's important to hire a licensed well technician. They provide professional expertise. They've been trained professionally with expertise in well installation, maintenance, and repair. Their knowledge ensures that all work complies with Ontario regulations and standards. They possess all the technical skills required to handle complex well systems, including diagnosing issues and performing repairs accurately. Water quality and safety. It's proper installation and regular testing protect water quality. And contamination prevention reduces risk of groundwater contamination. Their cost efficiency, accurate diagnostics. They can identify and fix issues early to avoid any costly repairs down the road. They ensure long-lasting solutions and fewer maintenance issues. They have to maintain well standards, and that's important for property transactions. Environmental care, they follow the best practices to protect the environment. They'll give you peace of mind with reliable service. Professionally handling provides confidence in well safety. And emergency readiness. Their quick response to urgent issues as they know how important your well safety is. If you are going to be testing a well, you can reach out to Public Health Ontario to request a drinking water sample collection kit for free bacterial testing. If you'd like a more detailed test, you can find a list of licensed laboratories here, and they'll provide a much more detailed chemical testing in your area. However, they do come with a fee. Inspecting your well can be dangerous work, If you're not familiar with wells, let an experienced licensed well technician do the work for you. And you can always go to ogwa.ca for more information on any of these. That's the end of my presentation, and thank you all.
Thank you so much, Trish, for your presentation. Kyle, will I be passing to you, or should I move into some of the questions?
Yeah, I've been watching some of the questions throughout the chat. We can start with our pre-submitted ones and then move on from there.
Perfect. I will just share my screen again. At this time, I'm going to ask my colleague Haven to read out some of the pre-submitted questions for us. Just going to find my way through here. Alrighty, I don't see Haven yet, so I'll just get us started here with some of these questions.
Oh, no, sorry, I'm here. I was just waiting for you to get to the first slide. My mistake.
Oh, no worries. There we go. Perfect. Thank you.
Okay, awesome. So the first question today that was pre-submitted, how at risk are we of droughts in the next 5 to 10 years? And I assume that this question refers specifically to the Ontario region.
Yeah, that's the hardest question to date. It's impossible to predict, but what we've had in the past is the areas like Napanee have shallow fresh water. And if you go any deeper, you get into salt water, into groundwater wells. So where we really see that drought is in areas where there isn't a lot of fresh water at depth. So here in Carleton Place, where my current office is, 4 years ago, we had our water levels in our municipal wells drop 3 meters. So if you only had 3 meters of standing water in your well, that would cause it to go dry. And it's really dependent on the areas that you're in.
Haven, you're just on mute.
My mistake. Thank you, Kyle. It's a great answer. We'll move to our next question now, unless anyone has anything to add to that from our team. Okay. How at risk are highly vulnerable aquifers, or HVAs, and why are they important?
Again, it's very much about the zones with the shallow, fresh water. It's closer to surface. It can get contaminated quicker, and typically the shallow fresh water is the only available fresh water. Did you guys want to move into more of that?
Sure.
Yes,
I work at the Mississippi Rideau Source Protection Region, and I just wanted to mention that protecting our highly vulnerable aquifers is extremely important. There are some high-risk land uses that may not be appropriate for development within these areas that, as Trish and Kyle mentioned, can lead to drinking water contamination. So it's important to note that municipalities in Ontario may have special requirements that may differ across the province for development within these areas. So if you're interested, reach out to your municipality to see if there's any official plan or zoning bylaw requirements that may restrict future development within an HVA. And you can find out also how each of our municipalities works to protect them. Thank you.
Thank you both. So our next question, I think perhaps Kyle and Marika will both answer this one as well. We'll just move the slide. What are development-related flags to look out for regarding groundwater resources?
My big two is dewatering and geothermal applications. Dewatering is regulated, and Nobody really plans about the background. So with dewatering programs, you can change the course of groundwater and move water into areas that it hadn't typically been. And if that area does hold a source of contamination, once the pumps go off and dewatering practices, that impacted water can then go back to the vulnerable aquifer that people are tapping into for drinking water. And geothermal, there's two types. There's closed loop and open loop geothermal systems. The open loop systems are essentially just a large diameter drinking water well that takes water out of one well and puts it into the other. We don't really think about temperature as a big thing with groundwater, but the difference of 1 degree can create a whole different ecosystem within the wells and introduce new bacterias. So open loop geothermal systems are one thing to really look out for new developments around your drinking water wells.
Thanks, Kyle. And I'll just jump in regards to future development, for example, a new dwelling or new subdivision, something of that nature. Your municipality may have additional requirements to demonstrate to them that you have good water quality and enough water. So they may require something called a hydrogeological assessment to be completed, which would be a prerequisite before getting approval to proceed with your development. Thank you.
Thank you. So our next question was submitted by a participant. And the question is, why might I smell sulfur occasionally in our water? Not all the time, but just occasionally.
I see this lots in sandstone formations, other sedimentary bedrock formations, and it's typically associated with weather events. So your spring thaws or large rain events, because what it's doing is it's replenishing a lot of water in that aquifer pretty quickly, and it's pulling water from further away to go through. So in normal use, without a big event bringing a new flood of water into the groundwater, you're typically working within an area, drawing from an area that's much smaller. But with a big event, it'll bring water from further away that could be impacted with sulfur and sulfur gases.
Okay, great. Thank you. Next question. Are there restrictions on how much groundwater households can use? Also, how do you know when your well is running low? And is a cistern the only option for a dry well?
Okay, so the restrictions in Ontario are capped at 50,000 liters a day. At that point, you must apply for a permit to take water. Our typical households, each person uses about 300 gallons a day, so we're nowhere near that. Your typical domestic well usually pumps between 10 and 15 gallons a minute. So within one 24-hour period, your typical domestic well cannot pump enough water to meet that 50,000 liter threshold to get into permits. And how do you know when your well is running low? On a lot of modern systems, the pumps have dry water shutoffs, and your licensed technicians, when they complete the pump test after the new well is drilled, they will know the capacity of that well and size the pumping system to it so that you do not go dry. Is the cistern an only option? In areas where there is low water volumes, north of Toronto, when you get up into Milton, there's very little groundwater. You can have wells that produce 1 to 2 gallons a minute. So in that case, you're going to need to get into a cistern or an in-basement larger storage. Some people have larger pressure tanks or storage tanks in the basements to avoid the large, costly cement cisterns.
Okay, thank you. That was super illuminating. The next question is, how does radon or other types of gas impact groundwater?
The radon is a gas that's dissolved in the groundwater. It doesn't affect groundwater. What it affects is our human reactions when that gas is off-gassed from the water. We typically tell people in granite, where their water is coming from granite or metamorphosed formations, that's where we can see high radon levels. It's not a problem till it gets into the house and into your breathing space. So we recommend that people test in their bathrooms after a hot shower. If you have elevated, you can get kits off Amazon that are pretty reliable and cheap for that. But if you do see those elevated radon levels, there's mitigation that we can do in the basement of the house with dual bladder pressure tank systems. There is the whole house systems that essentially circulate the air through your house to evacuate it, but they can be very costly because then you have to reheat that air in the wintertime. One of my favorites is a system called Airwell. It is installed within the well and gets the gas out of the well before it even enters the home, and that can treat radon gas, sulfur, and others.
Okay, thank you. We've touched upon this one a bit, but it's still a very important question to address. Why is it important to properly decommission wells that are not in use, and who should we contact if we do need to decommission a well?
So as a well owner, you are liable for any wells on your property. The old dug wells are a big hazard, not only physically for anybody walking around. If you're alone and fall into one, the water, you'll be hypothermic within about 5 minutes in cold groundwater. So there's that physical hazard, but also an unmaintained well has a standing water column that's exposed to air, and bacteria and other contaminants will grow in there and can spread throughout the aquifer. If that contamination were to spread to, say, another neighbor, you would be liable for that. So it's best, if you're not maintaining a well, get it decommissioned or abandoned. And who should do it? We need to hire a licensed well contractor with a technician of the same class to construct that well. In Ontario, there's 5 classes of well technicians, and each one is licensed to construct a type of well, and that gives them the ability to decommission that type of well. So if it was a bored well or a dug well, you would be hiring a class 3 technician. If it was a drilled well, you would be hiring a class 1 technician to abandon those respectively.
Okay, thank you. Well, on average, how expensive is it to install a new well?
In different regions of Ontario, it fluctuates a little bit, but a full well is about $15,000. And then for the hookup and installation in the house, you can be between 5 and 8. So a good $20,000 budget to construct a well is typical for a 100-foot deep well. Now, when we get into some granite aquifers where there's not a lot of water and we're reaching those 300-foot marks, that's when most well contractors have a footage price that can be anywhere around $60 to $90 a foot beyond 100 feet. So it can go exponentially after that. But $20,000 budget is comfortable.
Okay, and this is our last pre-submitted question for today. How often should a well be shocked, and how can you do it safely? Further, if shocking doesn't work, how can I find the source of contamination?
You only need to shock your well if there's an issue. If there's elevated bacteria or flogging from sulfur that may be plugging screens, we don't shock wells on a schedule because the exposure to chlorine to the fittings, brass and steel, will rot it out much, much faster. So we only want to shock when we need to. And homeowners are allowed to work on their own wells. I was even on Sudbury's, the town of Sudbury's site, and they had good instructions on how to dose a well or shock it. but the techniques were not there. The biggest thing, like I said, is exposure of that free chlorine to your casing, your fittings, your pitless adapter, which we talked about. And I think there was a question in the chat about what's a pitless adapter. It's a brass, I got one here. It's a big brass fitting that pulls apart so that you never have to dig up your well again. That's why we call it pitless. Typically, before this pitless was adapted or it was invented, all wells would have pits, which contain harmful gases and contaminants and vermin that just caused a lot of issues. So we've then developed this pitless adapter. And that way we don't have to dig up as much, but we need to protect those. If we were to pour chlorine directly onto brass, it will corrode and you will not get that pitless adapter apart, and you may look at a very costly repair or even a new well. So that's why we don't want to shock if we don't need to. So no schedule to shocking. And if anybody does want to shock their own well, the best instruction I can give you is use a drop pipe. Well, hire a licensed contractor first, but drop pipes to get that chlorine down into the water column without it touching your fittings or your exposed metal casings, because that will rot it out much quicker. And then if shocking doesn't work, how can I find the source of contamination? Further analytical testing, find out what that contaminant is. If it is bacteria, it could be coming from agriculture or your own septic systems or faulty casings. That's where you'd really want to get a licensed well contractor in, get some analytical testing, is find out what that contaminant is and then source out possibilities.
Okay, so at this point, I know we've had a very active chat today with lots of questions coming in live time. So I'm going to turn the mic over to my colleague Natasha at Quinte Conservation, and she'll read out those questions from the chat.
Awesome. Well, the first question here that I'm going to ask you, were some questions in the chat that are a little bit too technical. So if you do still have those questions, feel free to send us an email and we'll try and get you an answer. But for the first one I'm going to ask is, would it be possible to comment on natural contaminants such as manganese, which can exceed health guidelines in some areas?
I can talk to manganese a little bit. Often it's naturally occurring. The largest issue we see is plugging pumps and encasing wells. There are treatments for it. I don't particularly like them because if your treatment system fails, then you're ingesting that. If you can fix it from the well, that's what I always encourage. Fix it at the well. Don't treat it afterwards. So manganese, it's typically not pumped up through the systems. It coats the pumps, the casings, the natural bedrock. If you have a licensed contractor come out and do a remediation, maybe once every 2 years on your well, pull the pump out, scrub it, do a chemical treatment. That would be good for your typical manganese situations.
Wonderful, good answer. And then our next one here, has the Ontario Groundwater Association ever done any direct advocacy to call for restrictions on any of the chemicals you mentioned that you know are contaminants in their water? This might be a question for Trish. I'm not sure who would like to answer that one.
You want to go for it, Trish?
Well, I haven't been with the Ontario Groundwater Association for as long as Kyle has, so maybe you want to talk to maybe a little bit more of that.
Those contaminant situations are so massive. So the short answer is no, the Ontario Groundwater Association has not advocated to restrict those particular contaminants. What we do is we work with the National Groundwater Association, which is an American entity, and their lobbyists essentially battle for all of North America. So PFAS, the big one now, we are affiliated with the National Groundwater Association, which is lobbying through the states to regulate those specific chemicals.
Wonderful. And then the next one, is there a certain date or year or even decade that homes would have stopped building old types of wells?
Short answer is no. There are still people out there doing it today. The old style wells, certain areas, it's the only source of groundwater. I know just north of Belleville, Foxborough, there is so little groundwater there that we will construct the old style dug wells to today's standards. It's a little bit better, but then there's so little groundwater that in the soil that we actually use explosives to create a crater at the top of the groundwater for that water to pool and use. So people are still doing the old style wells where there's no other source of potable water.
Okay, that's actually surprising. I had no idea. But yeah. Another one here. How do our regulations protect against too much development from overtaxing the sources of water available? And do these regulations take into account the various topologies, for example, karst or highly vulnerable aquifers?
Yeah, we're involved in lots and lots of studies. We work with research groups. Marika said the big one is that hydrogeological studies, whenever there is going to be large development, it's a requirement for usually working under a consulting engineer with a hydrogeology background to ensure that the planned usage of the groundwater in that area does not impact existing wells and systems.
And I think this one here is a little bit tied to some of what we've already discussed today. They ask, can you tell me if the municipality bears any responsibility for local wells through zoning and planning?
Yes, absolutely. The city of Ottawa is a huge user and promoter of groundwater, so they set their own standards and have different casing regulations. And yeah, the municipalities do, where smaller municipalities really focus on is septic, is what we do with that wastewater in order to not impact the current clean potable groundwater. They often do not give any variances because that would then leave the township liable. One story I know of in Brockville, a homeowner wanted to build his new home. There was no room on the property, so he advocated and lobbied, and he got the township to ease the setbacks for septic and well for his construction. They constructed the well, they constructed the system within tighter than setbacks, and that well became contaminated from the septic system, and that homeowner was able to sue the township because they allowed it.
Yeah, so very important that the municipality has some responsibility making sure that the water sources are safe, especially for those rural wells. Another one here is there a benefit for the province to regulate standard casing depths on a region by region basis?
I don't see an advantage to that. I see a lot of red tape. The bedrock depths are so variable. Even within one municipality, we can have several different formations that would it would have to be custom to each well. And I don't think there's current staffing in place that could handle that volume of custom well design. That's why we want to always go with the licensed well contractors. the more local, the better, because some have spent generations in those areas and know that there could be poor water in the upper zones. So we want to case that off and go deeper to find, like the old drillers say, the sweet water.
Nice. Yeah. And then someone else just asked, invasive species, is there any concern for them potentially contaminating groundwater?
If they end up in the well, then yes, but I don't know if that would mean, fish or plants, things like that.
I think they specifically asked about plants.
Yeah. I don't know of any plants that will contaminate our groundwater. I can see if you had a toxic plant and it got into the well from, let's say, lawn clippings or something like that, then that could potentially pose a risk, but it has to end up in the well.
Yeah. And then there was someone else who asked, can I use laundry water for watering my garden beds? Or would that potentially contaminate the groundwater?
Most laundry detergents contain phosphates. Anything that's not natural can be considered a spill. We scrutinize it so much that even a freshwater release where there's not fresh water can be considered a spill. I know that some plants, you want to use soap for pest control. I don't really have any suggestion for that, putting soap onto the ground. I guess I'd say keep it in low volumes so that it evaporates rather than entering any groundwater systems.
Yeah, and we did have a previous webinar about treatment and testing, where we talked a little bit about gray water systems. So if you're interested in learning more, you can always watch that webinar. But from there, I believe that's all the questions from the chat. So now that
Natasha, sorry, if I may, the question regarding invasive species, we had the individual put in that they're not concerned about the groundwater contamination by invasive species, but are wondering if contaminated groundwater has contributed to the prevalence of invasive species.
I would say no to that.
Awesome. All right. So with further ado, I believe we have some questions for everybody here. We do this at the end of our webinars just to see if they're working, if we're teaching you something. So I'm just going to launch a few poll questions. If you could submit your answers to the questions, we greatly appreciate it. We use the questions, your answers to the questions, to help us determine how we did during the webinar and if there's anything we can improve on. So we'll just give a few moments for that. And again, if any of your questions, if they were pre-submitted or if they were during the webinar, if we didn't answer them, feel free to send me an email. You will get an email shortly after with the recording of this as well. So if there's anything that you missed, feel free to watch it again on YouTube. And while you guys are filling out those poll questions, I can maybe entice you to register for our next webinar. Our next one is in September. It's on harmful algal blooms, the signs and solutions of them. That's on September 25th, same time, noon until 1:30. And then we have one shortly after the next month in October. That one will be on climate change impacts on drinking water safety. And again, it is at noon until 1:30. And hopefully both of these webinars will be recorded and available on, they'll be available on YouTube afterwards. Alrighty, well, without further ado, I'd just like to say thank you to our presenters, Trish and Kyle. It was been great having you, extremely knowledgeable, and we really appreciate you coming here today to educate all of us on groundwater. If you do have any questions, the 4 people who help organize all of these are Kelsey and Haven from Cataraqui, Marika from Reno Valley Conservation, Trent Boss, who isn't with us today, but he's from Lower Trent Conservation, and myself from Quinte Conservation. If you have any questions, feel free to send us an email. But without further ado, it's been great having all of you, and we hope you have a great rest of your day.
Thanks, everyone.
Thank you.
Thanks so much. Thanks everyone for joining today. Enjoy the rest of your day.